Hi students, welcome to this session on electricity. We make use of electricity every day, isn't it? We use electricity to charge our mobiles, laptops, our AC, fan, TV, bulb, all runs on electricity. Our microwaves, toaster, grillers, all use electricity, isn't it? Our industries, they are totally dependent on electricity for their production. And nowadays, we see the electric cars running on the road. This is all possible due to electricity. So, what is electricity? In general, we can say electricity is a form of energy which drives all the machines, appliances around us. Now, where do we get this electricity from? We can get this electricity from batteries or from the generators or the power plants. A battery or a cell gives us DC current, whereas a generator or a power plant, they give us AC current. This is how a battery or a cell looks like. So the cell basically has a positive terminal and a negative terminal across which a potential difference is created. Now this works on the principle of chemical reaction, and during this reaction free electrons are generated which flow in the circuit to produce current. So this is the internal diagram of a cell. Okay. Now this cell gives us a DC current. So DC current is a current which remains constant with time. Since the potential difference across the two terminals of the battery is constant, so it also generates a constant current. So either we have a 12 volt battery or a 5 volt battery or a 24 volt battery, it gives us a constant current with time. And as the chemical or the electrolyte which is within the battery gets consumed, the battery becomes dead. So we need to replace this battery for the proper functioning of our circuit. Okay. So now the AC source is the main which is supplied from the power plant. This is basically 220 volt which comes to our house. Okay. So in our domestic applications we use AC current with 220 volt. Now this voltage in the AC supply fluctuates from positive 220 volts to negative 220 volts, and due to this fluctuating voltage the current also fluctuates. Now this AC current has a frequency of 50 Hertz. That means it completes 50 cycles in 1 second, and within this 1 seconds the voltage fluctuates from 220 volts to minus 220 volts. So that means the polarity changes 100 times in 1 second. It is 220 volt positive at one time and it is 220 volt negative at the other time. Now let us understand the potential difference and the current flow through a simple circuit diagram. Now this is a simple circuit diagram. We have a battery connected to a bulb through a switch. Now if the switch is open, there is a break in the circuit, so current will not flow. Now as soon as we close the switch, the circuit gets completed and current start flowing through the circuit and the bulb glows. This is a simple explanation of how current flows through a circuit. Let's see this diagram. So we have a power supply here, which is a battery, and we have the circuit part here. This is the power supply. Now unless we connect this battery to this circuit, there will be no flow of current. So basically what we can understand is this battery is creating the flow of current in the circuit. So now if I connect this terminal like this, the current will start flowing, and the switch is on, so the current will start flowing. So what we understand from this diagram is this battery drives the current through the circuit, and this current is generated because of the potential difference present across the battery. Now let us suppose a current I flows through this circuit through this resistor R, and the potential difference is V, which is in between the positive and the negative terminal of the battery. So V is our potential difference, and I is the current flowing through the circuit. So by definition, potential difference is the work done in moving a unit charge from the positive terminal of the battery to the negative terminal. Now let the charge be Q. And we know that the V is the potential difference or the voltage which is driving this charge across the circuit. So work done will be Q into V. Q is the charge which is being pushed by this voltage across the circuit. And we also know that current is equal to the total charge flowing through the circuit at that particular time. So we can also say the current I will be equal to the total charge going through the circuit in that particular time. That is charge by time. Okay. So let's make this equation 1 and let's make this equation 2. So now when we put the value of I from this equation, or my Q will be I into T. Let's take this as equation 2. So if I put this value of Q into this equation 1, so we get work done is equal to V into I into T. Now what is this work done and who is doing this work? So here work is being done by the power source or the battery or the potential difference. This potential difference is driving the charge Q across the circuit, which results in the generation of current, and this current is being used by the load or any appliances like fan, AC and bulb for their working or functioning. So work done is basically the amount of energy being supplied by the source or the battery to the circuit. So work done is the electrical energy W supplied by the source. Here the source is the battery. Or it can be the mains also. Right, with the battery or the mains providing the current I in the circuit. Under a potential difference V. So now here we got the relation between work done, current, voltage and energy. So we can say now that work done is equal to the electrical energy, isn't it? Therefore work done is equal to the electrical energy. Now let us come to power. So by definition we know that power is the rate of doing work, isn't it? So power is the rate of doing work, or we can say power is work done by time. Isn't it? Now from the previous calculation, what was the value of W? So W was, work done was V into I into T. So let us substitute. So my work done is V into I into T. Now this is divided by T, so this gets cancelled out. So my power is V into I. So power is V into I. The unit of power will be watt. So my power is equal to volt into ampere. So what is 1 watt now? 1 watt will be equal to 1 volt into 1 ampere. Okay. Now, why is it important to know the power? It is important because it gives us a clear idea about how many appliances can be connected to the circuit. What should be the power rating of the devices or appliances which we can connect to this circuit? This further helps us to reduce any overload conditions which can damage your devices. Let's see how the power from the power generating stations are sent to the customers or the consumers. Basically, the power stations which generate power are situated in remote areas quite far away from the cities. So on an average 50 to 60 kilometer, more than 100 kilometers sometimes, the power has to be transmitted to reach the consumers. So from this diagram we can understand how the power is transmitted. So basically this is the power plant. This is shown by a small diagram here. The power is generated in the power plant. Generally it is generated at 11 kVA. So now since it has to be transmitted to long distance, now we need to step up this voltage so that it can be transmitted to far off places to avoid much power loss in between the transmission. So now this step up transformers, they increase the voltage of the power. So this 11 kVA is increased to 132 kVA, and then it is sent through the transmission lines or the transmission cables. Now these cables bring this power to the substation. The substations are fairly near to the residential area or the commercial area, or they are within the cities, very near to the cities. Now here a step down transformer is used to step down this power from 132 kVA to 33 kVA, and from this substation now again it is sent through the distribution line, where we have one more transformer that steps down this 33 kVA to 11 kVA, and this 11 kVA power is sent through the distribution line which comes to the residential area or the industrial area or the commercial areas. Now when it comes to the residential area, the amount of power we require is basically up to 220 volts. So now this 11 kVA is further stepped down to 220 volts. Now this 220 volts power is given to the distribution panel, and from the distribution panel this power reaches our home, or basically it reaches the consumers. So if you carefully look at this diagram, you will get a fair idea about how power is distributed from the power station to the substation, and then to the distribution lines, then to the panel, and it comes to the consumers. Okay students, so we'll end this part here. Wait for the second part. We'll discuss the remaining topics in the second part. Thank you. If you like this video, please share and subscribe. Please support. Thank you.